We just looked at a reflected cross-site scripting attack. So that is one where the victim had to follow a malicious URL, and then the payload in the untrusted data was reflected back into the source code of the page. I want to show you another XSS attack though, and that's a persistent cross-site scripting attack. Now this is best demonstrated. So let's do this. I'm going to go over to the leaderboard, and then I'm going to go down and click on the Bugatti Veyron. Let's take a look at that vehicle now. It loads, and then very quickly it disappears, and we end back on evilcyberhacker.com. This is exactly the same resource that we saw just before. And in fact, the URL is the same as well. We can see the cookies reflected up there in the address bar. So how did this happen? What is the construct that made that possible? Well, if I jump back one, and then immediately after I click on the Bugatti, I hit Ctrl-U to look at the source code, and then do a find, again for Evil Cyberhacker, we can see exactly the same attack as we saw earlier appear here in the source code. Now, in a persistent cross-site scripting attack, the payload is persisted, so it exists in a data construct such as the underlying database. And in this case, what's happened is it actually appears in a comment. So someone has gone and left a comment on this website, inevitably Guido, we can see him on the line above this attack, and that comment has got the XSS payload. You wouldn't see this in the web interface because it's just a script tag, so there's nothing visibly rendered. But clearly it has been very effective. The really nasty thing about a persistent cross-site scripting attack is that you don't have to engineer the victim into following a malicious link. They just go to the site and use it as designed. And not only that, but the scope of victims now dramatically increases because anyone who goes to this resource gets hit with the cross-site scripting attack. Now this goes back to the previous module when I defined untrusted data, and I said that one of the sources of untrusted data is the request body. And what's happened here is that that request body, so that is the body that came when the comment was left on the vehicle, gets persisted. Now while we're talking about persistent cross-site scripting, in that previous module I also said that a source of untrusted data was external services. And I'd like to go and give you an example right now of what that looks like. In 2014, a security researcher wanted to demonstrate the risk of persistent cross-site scripting when the attack payload was persisted via DNS records. So that is, they created a domain and they added a DNS record, such as a TXT record, that had cross-site scripting in the value of the record. The researcher made a video of what this meant when a site designed to show DNS records didn't properly handle untrusted data from an external service. The best way to see how this works is just to watch this video that he prepared.
Con los terroristas.
Harlem Shake.
That is quite an impactful demo, and what it shows is that the researcher was able to get a site to run both CSS and external media simply by going to this Whois search site and loading up his domain name. So what he had actually entered into his DNS records persisted all the way through to the Whois site, came back out in the response when his website was shown, and executed in the browser. Now playing the Harlem Shake is really just a proof. Clearly there's not much of an upside for an attacker in getting the browser to dance around this way. But what it shows is that he was able to run this external arbitrary script in this particular Whois website. Now there have been many similar demos in the past, and in fact in my Pluralsight course on Introduction to Browser Security Headers, I show another video where someone demonstrated the ability to get Dutch banks to do this via reflected XSS. In that course, I also show how to prevent this style of attack, or indeed ones that are genuinely malicious, using the Content Security Policy browser header. So that one's well worth checking out. For now though, we've seen both reflected and persistent cross-site scripting. Let's go on and talk about how to actually defend against this attack, and look at some of the countermeasures we can use to stop it dead in its tracks.